Here's a nice trig equation. 2 sine 2 theta equals square root of 3. I'm going to solve for all values of theta. That way you can see how that works. So first thing I do here is this, when I notice that this isn't your typical just plain 1 theta or just x, I'm just going to do a substitution. It makes it a lot easier on us. So I'm going to let u equal 2 theta, and then I'm going to solve 2 sine u equals square root of 3. Go ahead and solve for sine u equals square root of 3 over 2, which is a number that's on the unit circle standard. So if I think about my unit circle, I know the angle where sine is square root of 3 over 2, I believe, is at pi over 3 in quadrant 1. And sine is also positive in quadrant 2 for 2 pi over 3. Okay, so that means that u is either equal to pi over 3 or u is equal to 2 pi over 3. Now, if we were just doing the angles in the first rotation from 0 to 2 pi, we would be almost done here. But since we're going to do all values, we have to add 2 pi k to each. So I include every single value in every single rotation I can think of. And remember, where k is an integer. K is not a real number. K is an integer. You need to make a note of it. Now, in the beginning, I needed to solve for theta, so that means I need to solve for theta in the end, not just u. So I'm going to substitute in 2 theta for u. I get pi over 3 plus 2 pi k. And then 2 theta equals 2 pi over 3 plus 2 pi k. So now the last thing I want to do is, you can say divide by 2 or multiply everything by 1/2. So I'm going to multiply by 1/2. Because I have a fraction here, it's just a little easier. 1/2 2 pi k. And over here, that gives me theta is 1/2 times 2 pi over 3 plus 1/2 times 2 pi k. And then one more step to simplify. Theta equals pi over 2 times 3 is 6 plus pi k, because these twos cancel. And here theta is equal to, well, those two cancel, so I'm left with pi over 3 plus pi k, where k is an integer. And there I have solved for every value of theta that solves my original equation.